Today's interview begins with a question that appears in many generative AI interviews. The interviewer writes AI interview question on the whiteboard for the candidate. The candidate realizes this concept decides whether many engineers pass or fail the interview. The interviewer asks how modern AI models actually learn language. The whiteboard now highlights how AI learns as the key topic. The candidate pauses, thinking of a simple way to explain it. The candidate says the answer is surprisingly simple once you see the idea. The interviewer points toward generative AI training written clearly on the board. The candidate promises that the explanation will make the concept easy to understand. The candidate says the secret behind modern AI is actually a clever learning trick. Today's discussion focuses on self-supervised learning in AI systems. The interviewer listens carefully as the explanation begins. The candidate says the idea can be understood through a very simple story. The whiteboard now shows learning from data as the key concept. The interviewer leans forward, curious to hear the story. The explanation begins with a simple learning puzzle. The board introduces missing word puzzle as the first example. The interviewer studies the example carefully. A sentence appears on the whiteboard with a blank space. The candidate circles "guess the missing word" written beside the sentence. The interviewer begins thinking about possible answers. The example shows how a model tries different guesses. This training task asks the system to predict the hidden word in a sentence. Patterns slowly begin to appear. Many similar sentences appear around the board. These examples reveal pattern discovery happening in language data. The interviewer nods slowly. As the examples increase, the predictions improve. The model gradually learns through language patterns found in the text. The interviewer begins to understand the idea. The explanation now introduces another learning game. The whiteboard displays next word prediction as the new task. The interviewer watches the example closely. A partial sentence appears on the board. The model must predict the next word using the context of the sentence. Several possible answers appear beside it. Another example sentence about grocery shopping appears. This training scenario demonstrates next word guessing in action. The interviewer clearly sees the pattern. The system repeats this process billions of times. Each example strengthens the model through prediction training. The AI gradually becomes more accurate. Over time, the predictions become more reliable. The system slowly develops language understanding from these examples. The interviewer observes the improvement. The board now shows many sentences connected together. These examples create training patterns inside the model. Relationships between words begin to form. Some words appear together more frequently than others. The AI learns these relationships through word connections in the data. The interviewer nods in agreement. The model now predicts words more confidently. This improvement comes from repeated predictions during training. The explanation continues. The discussion shifts to traditional machine learning. Older systems often required human-labeled data for training. The interviewer remembers this approach. Images labeled cat and dog appear on the board. Each example contains manual labels added by humans. This process requires time and effort. The candidate explains why labeling massive data sets becomes difficult. This challenge pushed researchers towards scalable AI training methods. The interviewer understands the motivation. A smarter training strategy now appears on the board. This strategy introduces self-generated tasks for the model. The interviewer looks impressed. The system begins creating its own learning puzzles. The model automatically produces training examples from raw data. No human labeling is required. A word disappears from a sentence on the whiteboard. This hidden word creates automatic supervision for the model. The system must recover the missing word. The model predicts the missing word correctly. This successful prediction improves model learning. The system becomes more accurate. Millions of these puzzles appear during training. Together, they create massive training data for the model. The interviewer looks surprised by the scale. Books, websites, and conversations appear as sources of text. These sources provide internet text data for training. The model reads enormous amounts of information. An AI brain diagram connects many sentences together. This network forms language knowledge inside the model. The interviewer studies the visual carefully. The system now begins understanding relationships between words. This ability grows through context learning during training. The AI becomes more capable. The explanation now connects to modern generative AI systems. Today's models rely heavily on large-scale training. The interviewer nods with interest. The diagram now shows modern conversational AI systems. Many of these models use self-supervised training during development. The interviewer recognizes the connection. The explanation highlights the key idea again. This approach is known as self-supervised learning in AI research. The concept becomes clearer. The diagram simplifies the training process. The arrows illustrate data becomes teacher for the model. The interviewer smiles. The explanation now moves toward a simple definition. The board highlights simple definition for the concept. The interviewer waits for the final answer. The candidate delivers the final explanation confidently. The candidate explains self-supervised learning as AI learning by predicting missing or next parts of data using the data itself. The interviewer nods with understanding.